math lovers. Today we're going to work on notes number 114, lesson 6.3 from your Honors Algebra 2 textbook. A couple things I want to recall before you guys get started on today's lesson. I want you to think about your distance formula. We're going to use our distance formula today. Remember to find the distance through 2 points, x1 and y1, y2, x2, y2. What we're going to do is take the difference of the x's and square them. We find the difference of the y's and we square them. Now think about it. If one of your coordinates is 0, 0, right? If it's going to go through the origin. So if we go through the origin, okay, what is that distance going to be? Well, that makes sense that it would just be whatever x1 squared plus y1 squared, right? Wouldn't I just take those coordinates and square them and take their sum and then take the square root, okay? I could also use my Pythagorean theorem, right? Also use Pythag, which is also a great way to find the distance, right? To find our distance. All right, so those are some things to keep in mind. Okay, so as we get started here in lesson 6.3, I want you to think about theta, your angle measure. Now, we've got theta on the coordinates, on the xy coordinates. So if this is my y axis here, this is my y and this is my x axis. I've got some measure here, some radius for my angle measure. We'll call this from here to here. This is called r. I'll make it r. And I have some coordinate here, x, y. All right, this is my coordinate x, y. I'm going to move over in the x direction and up to y to get that coordinate. So let's think about our 6 trig identities. We have our sine, our cosine, and our tangent, right? Well, let's think. So we learned that sine, cosine, and tangent. Sine is opposite over hypotenuse. I know that sine is opposite over hypotenuse. So as I'm going through and I'm thinking about opposite over hypotenuse, I can think about, sorry, I'm getting settled here. I can think about my opposite. So my opposite side, well, let's drop an angle here. Let's drop a side, make it a right triangle, okay? This is our x value. This is our y value right here, okay? So sine is opposite, so that would be y over our hypotenuse. Well, in this case, let's cut this off here. All right, let's cut that off. Let's make that r. So this is going to be y over r. Our cosine value is going to be adjacent over hypotenuse. So our adjacent side, which is going to be x, over hypotenuse, which is r. So that would be x over r, okay? And our tangent, remember our tangent is opposite over adjacent. So our opposite, which is y, and our adjacent, which in this case is x, all right? So I'm going to think about the sine, cosine, and tangent today in terms of coordinates, x, y, and of course our radius r. And if I'm thinking about sine, cosine, tangent, you know I have to start thinking about cosecant, I have to think about secant, and I have to think about cotangent. Let's put those thetas in there. Can't leave those out. Now, I know the relationship between sine and cosecant, and they are reciprocals. So that would be r over y. The secant and cosine, they're reciprocals. So that would be r over x. And cotangent, the relationship between those would be x over y. But here's my problem. Think about my x and y coordinates. What do I have to know? I know that they're not equal to 0, right? I can't be talking about an angle measure of 0 as I work through these. So I have to say y not equal to 0. I have to say x not equal to 0 here. And here I have to say, again, y not equal to 0. All right, we're just going to put those in there. I really don't have to think about it over here because I would not have a measure if r were the measures. But I probably should put it here. I should say x not equal to 0 in with my tangent, okay? All right, so I have my distance formula I need to remember. I have my chart here. Now, I want you to think about how that looks on the Cartesian coordinate system. If I know that the sine is the y value, right? My values for my sines in my quadrant here, my first quadrant, they're going to be positive. My second quadrant, they're going to be positive. But as I get to my third quadrant, it's going to be negative, isn't it? So I can think about my values on where they're positive and negative. So think about my quadrants, all right? I'll draw a little tiny Cartesian coordinate system here. All my signs, because my x's and my y's are both going to be positive in the first quadrant. Here we say that all signs are positive. All functions are going to be positive. Okay, easy to remember. As I get into the second quadrant, as I work over here, my x values are going to be negative. So what is going to have a value with x? Well, that's going to be my cosine. That cosine is going to be negative, isn't it? So my cosine is going to be negative, and so is my tangent. So here we could say that sine is positive, and we can also say that cosecant is positive. Okay, those are our positive values. As we look into our third quadrant, our x value is negative and our y value are negative. So the only thing that's going to be positive in that quadrant is going to be a negative divided by a negative. So that would be our tangent, and our cotangent will both be positive. And finally, our fourth quadrant, where our x is positive and our y is negative. So we would have, let's see, our y is negative. So that means sine and tangent are negative. That means that cosine and secant are both positive. Now, friends, this is a lot to remember. Okay, so this is how we say all students take calculus. All students take calculus. All your signs are going to be positive in quadrant 1. Your sine and your cosecant will be positive in quadrant 2. Your tangent and your cotangent in quadrant 3. And your cosine and your secant in quadrant 4. Okay, so that's really going to help you go through the problems. All right, so this is what you're keeping in mind as we go through all the problems today. I'll just draw a little line to keep it nice and neat. I'm looking in your textbook on page 475. I'm going to start with number 13. Okay, so number 13 does give me quite a different looking angle. All right, 13. I have a quadrant. Let's see. It says the point on the terminal side are of angles in a standard position. Determine the exact values of 6 trig functions of the angle. And in number 13, they're giving me, let's see, negative 5.4 and 7.2. So what is that going to look like? Negative 5.4 and 7.2. So that's going to be up here. I've got negative 5.24 and 7.2. All right, so there it is. There's the ordered pair. Interesting. Let's see. My x value, what's my x value? My x value here is negative 5.4. My y value is 7.2. And what is my radius? I don't know what my radius is. Well, I can figure that out. Go back to what I said here, going through the origin, right? The points going through the origin. My radius is going to be equal to the square root of negative 5.4 squared plus 7.2 squared. So my radius, once I figure that out, it's very nice and neat. This is going to add up to 81. Square root of 81 is 9. Okay, so I've got my x value, I've got my y value, and I have my radius. They're asking me to find the sine, the cosine, the tangent of each of values. So sine theta, cosine theta, go ahead and write it down, tangent theta. Sine is going to be y over r. So in this case, I'm going to have 7.2 over my radius of 9. My cosine is going to be x over r. So that's going to be negative 5.4 over my radius of 9. My tangent is going to be my y over x value. So this is going to be 7.2 over my x value of negative 5.4. Friends, all I have left to do is reduce these fractions, okay? Suppose you're here quarantined and you do not have your calculators. You know this 72 is 7.2 over 9 is the same thing as 7.2 over 90, which reduces to 4/5. This reduces to negative 3/5. And over here, this reduces to negative 4/3. Okay, very nice. And then, so if I can go ahead and I find my reciprocal functions, I would have, let's see, cosecant of theta is just going to be reciprocal. So that's 5/4. I've got my secant, which is going to be the reciprocal right here of 3/5. So that's negative 5/3. And my cotangent, oops, forgot my theta, is equal to the reciprocal here. So that's negative 3/4. Okay, so I've done exactly what the question asked. I found the ratios of all the sides given that ordered pair. Okay. Number 23, a little bit different kind of question here. Number 23 says, Find the values of the 6 trig functions of theta with the given constraint. All right, so 23 is telling me I have the cotangent is equal to -3 and cosine theta is greater than 0. All right, so they're giving me 2 parts. Let's see where I can fit this in. Let me do 23 right here. Put a little line here. All right, so I've got the cotangent of theta is equal to -3. And they're also, this is my given. Miss Murphy would be so happy. And they're also saying that the cosine of theta is greater than 0. I'm drawn to the cosine theta is greater than 0. So where is cosine positive? So this is going to tell me that this is in quadrant, either quadrant 1 or quadrant 4. Okay, it's quadrant 1 or 4. All right, I know that straight up. Now let's see. I've got cotangent is -3. I'm thinking about cotangent. Well, cotangent, let's go back to cotangent up here. Cotangent of theta, let's see, cotangent of theta is equal to x over y. I don't know about you, but I'm thinking about this -3 as a fraction. -3 over 1. I think I have it. The x is -3 and the y value is 1. Quadrant 1 or quadrant 3? Which do you think? Well, it can't be quadrant 1, can it? Well, can it? Let's see. Let's draw it. So if I have, let's see, if I go over 3, I can't, this is not going to work. I can't have a -3 and a +1. That's not going to work up here. I've got to switch my signs around, don't I? I've got to make it +3. So move over +3. And then -1 and drop down here. This would be -1. Okay. I know my distance is really negative. It was really not negative, but I'm going to show it that way for the time being. All right. So this is my theta. My angle measure is always close to the origin. So I'm left. They want to know all 6 trig functions. Yeah, all 6 trig functions. I'll do the first 3. You guys know how to do the rest. That would be the sine theta, cosine theta, and the tangent theta. All right. So let's go back. Sine is y over r. Cosine is x over r. And then tangent is going to be y over x. All right, so I'm going to go ahead and I'm going to plug my values straight on in. If my x value here is +3, my y value is -1. Hold on, hold it up. I did not find the hypotenuse. I need to find r. How can I find that radius? Well, let's see. 3 squared plus 1 squared is 10. So my radius has got to be the square root of 10. Okay, easy peasy. So let's see. I've got my y value. So -1 over root 10. You guys know you can't leave it that way. So that's going to be -√10 over 10. Okay. And then your cosine here, which is the x value. So that would be 3 over root 10. But you know you can't leave it like that. So it'd be 3 root 10, or root 10, 3 root 10 over 10. And then my last one is my y over my x value. So my y value in this case is -1. My x value is 3. You guys can go, I know you can finish the second half where you figure out your cosecant, your secant, and your cotangent from that value there, okay? I'm gonna let you do that on your own. Okay. The next topic I need to talk about are reference angles. So let's see, a reference angle. A reference angle is your helper angle, the angle that's going to help you out. So reference, actually, is there a nice, I think there's a nice picture in the textbook of your reference angles. All right, so on page 469, here are my reference angles. Your reference angles are going to be your helper angles. The definition here says, let theta be an angle in standard position. So standard meaning it's, on the Cartesian coordinate system and you've got it close to the origin. Its reference angle is the acute angle theta prime formed by the terminal side of theta and its horizontal axis. So it's the acute angle that's going to help you out. Okay. So let me show you. So if I have, you still see it on my paper? Yeah. So if I have an angle in the first quadrant, theta, I don't need a reference angle to help me out because it's itself, okay? But if I have an angle here in the second quadrant, like here's theta, all right? I need this angle here, this theta prime. That's going to be my reference angle. Theta prime is going to be my reference angle. And here, if I had quadrant 3, my angle is going to come all the way across here. What's going to be that angle that's going to help me? Well, it's the angle that it's setting up here with the x-axis. So this angle here is going to be my theta prime. All right, so this angle here, I'll make it green, is my theta prime. Okay. And then finally in my fourth quadrant, okay, my angle would go all the way around to here. My reference angle is going to be right here. This is my theta prime. It's going to be the acute angle. It's your little helper angle. Help you make the picture. It's the one that you're going to make that right triangle with. It's the one you're going to make the right triangle with your x-axis. Okay, so that's what you're going to go ahead and do. All right, big day. I'm moving on to the back of the paper here. Exciting, talking a very long time. All good stuff. All right, number 41 in the textbook asked me to find the reference angle. Number 41, find the reference angle theta prime and sketch theta in standard position. So on page 476, for those of you following along at home, I have a 160-degree angle. So I'm thinking to myself, what does a 160-degree angle look like? Well, this is 160 degrees. Theta is equal to 160 degrees. I just showed you on that last page where that reference angle is. It's going to be right here. It's theta prime. And that theta prime is what's going to help me make that 180-degree angle. So this angle measure is going to be 20 degrees. Okay. Similarly, in number 45, on the same page, I have, let's see, a reference angle. Theta is equal to 2 pi over 3. Oh, good one. Good one. All right, 2 pi over 3. Same kind of thing. All the way around here, 2 pi over 3. Put the pi in there. 2 pi over 3. So how big is this theta? How big is this angle going to be here? I know halfway around the circle is going to be pi. So I know theta prime is going to be pi minus 2 pi over 3. And that's going to be pi over 3. Okay, so theta prime is this angle right there, theta prime. So your reference angle is just the angle that's going to go ahead and help you. Nobody's going to come along and say, hey, what's the reference angle to this? But you're going to need the reference angle to help you do all the problems that go along with this. One last one today. We're going to work on number 53 here. Number 53 says, evaluate the sine, cosine, and tangent of the angle without using a calculator. So I want to know the sine, cosine, and the tangent. Okay. Cosine and tangent of let's see, 150-degree angle. Okay, 150-degree angle, 150-degree angle. All right. Let's see what this is going to look like. All right. So 150 degrees. Let's see. That is... Oh, wait a minute. Hold on. Hold the phone. It's negative. That changes everything. Negative 150. That means I'm starting this direction and dropping down. So I'm going to go right to here. Theta is equal to negative 150 degrees. You know what I need? I need a reference angle. Okay. And my reference angle is going to be theta prime. And I know from just looking at it, you guys are thinking that it's going to be 30 degrees. All right. So in order for me to think about the sine, cosine, and tangent here, what I'm really going to do is I'm going to think about the sine of 30, right? I'm going to think about the cosine of 30. I'm going to think about the tangent of 30. And then what I'm going to do is I'm going to then take my answer and think about my sine. We started this lesson talking about all students take calculus. Where is it positive? Where are the values positive? So think about it, kids. All students take calculus. We're talking here about quadrant number 3. And so we know the only answer that's going to be positive is going to be our tangent. We know our cosine is going to be negative, and we know our sine is going to be negative. So right away, I'm going to put those answers right in there. Okay. Now, guys, think about your right triangle trig. It's coming back. All that stuff you learned in geometry. Those of you that said it wasn't important, guess what? It's important. Okay. Your right triangle trig, we're talking about a 30-degree angle measure here. Our ratios, 1 to 2 to root 3. Okay. 1 to 2 to root 3. So my sine, what's my sine going to be? the sine of 30, that's 1/2, right? Sine. Oscar had opposite over hypotenuse, 1/2, but it's going to be negative, so it's 1/2, negative 1/2. Cosine, Oscar had a heap adjacent over the hypotenuse, so that's going to be √3 over 2. And tangent, tangent's going to be opposite over adjacent, so that's going to be 1 over √3, and we never leave it that way. It'll be √3 over 3. Okay, so look at that. We use the reference angle of 150 degrees, which was 30, to go ahead and find the sine, cosine, and tangent without a calculator of those angle measures. Okay, remember, have fun. You're going to do homework number 114 tonight. Okay, 114. Don't skip any. Be good.